Professor Stella. You said that I have to call you Stella. It's kind of weird.
Of course, just call me Stella.
So it's
Professor
okay.
Stella. I call her Professor.
Is that Jensen or is that AI?
Professor Christie.
Okay, but then I will call you Professor Stella, is okay?
Yes.
Okay, Professor Stella. So your core research is about cognitive research, right? It's about how human think, how human learn, how humans solve problems. So can you explain to us about this cognitive research related with the AI development?
Sure. I first want to say what a great honor to be here with two amazing people, with Jensen and with Professor Ayu. And with all of you, it's such a great honor. Thank you for having me here. I think, Jensen, you've met some of these people, but I am told that we have thousands and thousands of young people watching us right now. So, hi everyone online. It's what a wonderful thing to be here. So, about cognitive research, I think, Jensen talked about intelligence, right? We've heard about we need to own our intelligence, and that is exactly what cognitive scientists do. So, my own research is try to understand what really is intelligence, like what is the origins of intelligence and what is the mechanism that bring us to intelligence. And one thing that's very interesting that I want to share with all of you is that intelligence is not as you think that, the really amazing AI only, or if you think about the most intelligent person like Einstein. Intelligence is everywhere. The fact that you know how to sit. Do you know how difficult it is to sit? Because you have to calculate every single movement of your body and calculate the pressure, the momentum, everything in order for you to be able to sit well. That's intelligence. And so behind all those, we try to understand what is the algorithm that gives rise to those seemingly simple but very intelligent movement. So there are two things that are very interesting if you look at now the human side, so to speak. The first one is that we now know that humans, unlike AI, actually can thrive from very small amount of data. So with just a small amount of data, 6 months old can already distinguish between cats and dogs. And they would never make mistakes. And there are actual studies that 6 months old can tell apart cats and dogs. And you know that even now with the amazing AI, image recognition is not 100% correct with cats and dogs. And if you think about 6 months old, how many cats and dogs have they seen? How many? Take a guess. I mean, certainly it's not billions. It's probably not even in the hundreds of thousands, right? But with just maybe thousands of images of cats and dogs, you are able, a 6 months old are able to distinguish and abstract what is a cat and what is a dog. And we still don't know what is that representation. So that's the first one. Humans can actually learn from a very small amount of data. The second one, humans, like AI, employ statistical learning. So AI, LLM is trained on a huge amount of data and try to make sense from that amount of data using statistics. Humans use statistics as well. So if you think about it, a 3-year-old were never told how to actually, what is exactly the grammar of their language. In Indonesian, we say buku merah. So the noun first, then the adjective afterwards. But in English, it's the other way around. Red book, the adjective before the noun. And 3-year-olds growing up in Indonesia and 3-year-olds growing up in 3-year-olds going out in the US are never told about first put the noun or first put the adjective. But can they do that? And that's using statistical learning. So the statistics are there. But one thing that's really interesting is that a lot of the deep insights don't come from statistical thinking. Instead, a lot of the deep insights actually come from analogical thinking, from seeing relations and similarities of patterns between events and between domains. So one of the best example is Niels Bohr. So many of you probably know that Niels Bohr won the Nobel Prize for discovering the structure of atoms. Do you know how he discovered those? He didn't discover that from getting so many data. Instead, well, that too probably, but instead, the insight, the key moment of insight is that he looked at the structure of the solar system and he asked himself, maybe even though the sun and the atom are very different things, but maybe the structure is the same structure. And that's what brought his insight. And that's what I call analogical thinking. So these two, being able to use a small amount of data and having insights from seeing patterns, seeing similarities, analogical thinking, is what we have understood now by a really great algorithms that humans can employ in order to produce great thinking. Yeah.
Thank you, Professor.